Aleksandra, Osowska-Kurczab, go ahead.
So, hi everyone, thanks for joining the talk. My name is Aleksandra Osowska-Kurczab. I'm a machine learning manager from the recommendations research team. And today, I have a great pleasure to be here on stage with Jacek Szczerbiński, from a research engineer from Semantic Research. We're working together in the machine learning research team, a research lab focused on innovative AI solutions tailored to the needs of Allegro platform. Today's talk, Understand, Translate, Respond, aka clever language modeling, will be focused on our two recent success stories, machine translation and intent discovery. We'll give you a sneak peek into the backstage of machine learning projects innovating the daily life of Allegro customers. I'll start with very brief, three quick facts about Allegro. We are the largest e-commerce established in Europe, and we right now operate in Poland, Czechia, and Slovakia. We have more than 20 million active customers, half of the population of Poland. Our customers love us. We perform on par to such giants as Apple or Netflix. And actually, Allegro is fueled with machine learning. AI enhances findability experience, manages the product catalog, and supports customer service. It wouldn't be possible to cover all of our projects, so we've chosen two of our big success stories for today's talk: machine translation and intent discovery. What can you expect from the talk? We'll start with a warm-up, quick intro into current state of NLP, or to be more precise, pre-training, fine-tuning paradigm. Then I'll show you that Allegro is, I would say, a reasonably sized text corpus to become an arena for experimenting with NLP methods. Next, some practical applications and our path to success in the two mentioned earlier projects. And lastly, we'll answer main question of the whole talk. So can we be cost effective and on par with SOTA in the current era of NLP? And we'll stay with you after the talk to answer any questions. So please feel free to approach me and Jacek and strike any question that comes to your mind. So let's jump right into the warm-up. So NLP, natural language processing, what is the current status quo? NLP is driven by language models, so some statistical models that for a given sequence of words, tokens, predicts the probability of the occurrence in the given context in the sequence. To train it, we need three basic ingredients. So corpus, a large body of text, a model, usually transformer-based, and a training objective, either masked language modeling or text generation. Our datasets for downstream tasks are usually not large enough to train such model from scratch. That's why we need pre-training phase on large and general corpora of natural texts. Fine-tuning can be performed with any particular objective suitable for the application of the model in production use, even if the dataset is very small. So while pre-training gives us proficiency in handling natural texts, it is the fine-tuning that is crucial for accuracy. So let's jump into our available corpora at Allegro. So, believe me or not, Allegro itself is quite a corpus. Over 300 million offers, 120 million products, over 1 million of daily messages between sellers and customers, help pages, media articles. If we've printed them all into a form of medium-length books, we will end up with more than 1 million of them. So you can agree it is a decently sized library. The corpus is naturally diverse. So let's take a look at this phenomenon. We can separate two groups of Allegro dialects, the standard written Polish language and the e-commerce one. So how can we divide our corpus into this landscape? Media articles and customer service logs belong more into general Polish language, while offer descriptions and product catalog is a great example of e-commerce lingo, so full of proper names and parameters. If we take a look at this landscape, we'll notice that Allegro has a large linguistic richness, which may be difficult to cover with only one model. And in fact, we've developed many specialized models that are adapted to specific language domains. So some of them are released as open source, for example, Herbert or PLT5. Some are our internal models used only in production environments. Mailbird, DescriptionBird, ProdBird. And probably if you've worked with NLP on Polish texts, you might recognize our models. If not, we really encourage you to experiment with them. Take a look at our Hugging Face. Link can be found at the end of the presentation. Okay, so we already know the pre-training fine-tuning paradigm and dialects of Allegro. Let's jump into the first application, machine translation. In machine translation, we have input texts in language A. So, for example, the word cześć, hello, in Polish, and we want to get a translation into language B. For example, Czech, ahoj. The process will be managed by a service that has a translation model underneath and some rules around it that allow for handling edge cases. Generally, there are already several such models that probably most of you use on your daily basis, for example, Google Translate, DeepL, Bing, etc. So what is our task here? What do we have to translate? When you visit any offer on Allegro, you will notice several elements apart from the navigation and page structure. First of all, each offer has its own title and description. In addition, we also have products, and they also have their own name and description. Moreover, the corpus includes some help pages, news articles, and the entire corpus needs to be translated before launching a platform in another country. So let's say that the most important challenge is to translate 300 million offers and 120 million products into the languages of the Allegro group, including Czech, Slovak, etc. So we can either create our own internal translation service or use our competitors' solutions. If we take an off-the-shelf model, we can expect that the solution will be relatively simple and quick to implement. Unfortunately, we cannot expect it to be tailored to our needs and our dialects. Moreover, this solution is not very cheap and lacks scalability, because each time when we expand our operations to new countries, it would involve quite large one-off, but also fixed costs. After all, each new offer that comes to the platform must also be translated. So these costs will continue and increase as the platform develops. What is the alternative? Of course, we can build a translation system within the organization as one of our projects of our lab. We can ensure cost effectiveness, and we will receive a solution that it will be tailored to our platform, which we can scale to as many languages as we like, because we have this magic know-how within our team. Of course, there is one downside. It may simply not work. But as we say, fortune favors the brave. And as you can guess from this talk, we decided on the latter approach. So the entire service consists of 3 modules. The first, the heart, the neural model. Its task will be to predict the most likely word in the sequence. The querying of the model is usually managed by a beam search algorithm, which, based on some predictions from the model, the sequence of such predictions will determine which output sequence of tokens maximizes the conditional probability for the whole sequence. The entire service would not be complete without an additional module that controls special cases. For example, when the NMT model recognizes numbers, tags, HTML code, emojis, proper names, etc. The implemented models are served on the CPUs. In the event of a large one-time need for translation, we scale our resources in our internal data center at night when the traffic on the platform is low. This means that we can translate almost for free. Okay, but let's get to the point. Let's take a look under the hood of the model itself. The training of our models consists of several stages. The first stage, training of several parallel large models called teachers. These models will be accurate, but quite slow. Therefore, we'll reduce them using a distillation paradigm to a single so-called student model. The student is taught to reproduce the predictions of the teacher's model despite a very reduced number of weights. Each module is a vanilla transformer. We use symmetry in the size of the models. Both the encoder and decoder have the same size. To further speed up and slim down the model, we use fourfold quantization, which will allow us to process data through the model much faster while saving resources. And from now on, we will treat such a lightweight module as our final NMT model architecture. So what data was used to train this model? The training procedure consisted of 3 stages. First, we need to adapt the pre-trained model to the everyday language corpus. Fortunately, the Czech language is not too exotic. There are some open datasets available that are aligned to Polish and can be safely used as data for model training. So, for example, you can use parts of Common Crawl or European Union documents or movie captions. The second stage of training is to train the model on the e-commerce language corpus. So how to obtain such data? We can filter the set from the previous step by some set of rules, or search the scraped data for e-commerce domains, so from the Common Crawl. In our case, we are lucky to have joined the MOL group, and we can easily use their aligned translations that worked on MOL-PL and MOL-CZ platform. The last step is to adapt to our specific Allegro dialect. And we can only use this source at the model distillation stage. We have no choice here, but use back translation from Polish, because Allegro never operated earlier in Czechia. So how does this whole process translate into accuracy? We'll start with the multilingual MBART 50 model, which does not do a particularly good job of modeling Czech. After training the model on the Czech language corpus, we observe a huge gain of up to 20 percentage points. The next steps of retraining will give us an additional 2 percentage points in total, thanks to which we can reach the level of accuracy similar to Google Translation Service evaluated in our downstream tasks. But I left out a very important element here, which is the metric. So how to evaluate a translation system? We can try to evaluate it like any other machine learning model. So given the validation set, we will quantify how often the model is wrong, using metrics such as BLE or CHRF. These metrics will allow us to determine how closely the proposed translation is consistent with the target text from the validation set. The only problem is how to obtain the data set, since Allegro does not have a source of Polish-Czech validation set that would be of a stable, good quality. A natural choice is to have examples annotated by language specialists. And that was our initial approach. We hired an external company whose task was to prepare translations of text from our platform. But as you might expect, we are very much dependent on the quality of their work. And actually, it was a loophole. Imagine what would happen if annotators were using some other machine translation service to speed up their work. So it actually happened to us. Annotators introduced bias into our dataset. But we can use annotators in a more reliable way by defining a more general quality assessment task. So let's imagine we want to compare 2 models. The annotator's task is to evaluate 2 examples on the scale of 1 to 7. A score above 5 means that the translation is acceptable. Below 5, that there are some errors. Such an assessment is carried out in parallel by 5 annotators and aggregated to a final score. Having such result grids, we can impartially calculate metrics such as mean opinion score or acceptable translations rate. And with a reliable test set, both methods of evaluation, quantitative and qualitative, should bring us to the same conclusion. The only drawback with the qualitative method is the presence of annotators, which is an additional cost, of course. And actually, we have a solution for that, which is an automated referenceless metric based on Comet. And if someone wants to have more detail on that, just please approach me after the talk. I will tell you some more details about it. So, knowing the architecture, the evaluation, the data set, everything, let's jump into the results. So on the left, we can see the acceptability of the translation of our MTE service compared to Google Translate in the downstream task of translating Allegro texts to Czech. A darker color means victory. So we are practically on par with Google. We win in 50% of the issues, and the remaining ones, we are not far behind. Interestingly, you may notice that machine translation models cope much better with longer texts than with short ones, such as title of the offer or the name of the product. Unfortunately, this is the nature of our data. Titles and names are very condensed telegraphic text, which is not like very much abundant in the training corpora of translation models. So we were also intensively working on the Slovak model. And looking at the model results, we can safely say that we outperform all of off-the-shelf solutions, even Google Translate, in our downstream tasks. The Slovak language is a low-resource language, and it is more difficult to obtain sufficiently rich corpora for it. But we managed to do it. If I were to tell you like 3 things that led us to success in this project, it would be rich dataset, proper fine-tuning, divided into 3 steps, and careful evaluation. And actually, it is the edge that we can have over big universal models provided by technological giants like Google. So just let me finish off my part of the presentation with a call to action: embrace the challenge of domain adaptation. And Jacek, please join me on stage.
Hello. Not yet? Okay. No? Klikam, ale... Dobra. No mogę klikać. Dziękuję. Nie. Dobra, jedziemy. As you just saw, in the case of machine translation, we achieved state-of-the-art performance with almost no involvement of human annotators, right? They were used only at the very end of the process to evaluate the model and tell whether it's good enough for deployment. So now the question is, can we possibly do the same thing with customer service? And I'm sure some of you are just dreaming about that, right? But actually it's not that straightforward. So let me tell you the story. Our customer experience receives about 20,000 questions per day. And in the peak holiday season before Christmas, it's up to 35,000. So we have to automate. Okay, if we wanted to answer all of those questions, we wouldn't even be able to hire enough people. We automate on 2 levels. First, if you ask a question at Allegro, then our chatbot, Alina, will give you an instant response. And if you're happy with the response, then your message will not even be sent to customer experience. But if you still want to send it, then the CX consultant will see your message along with the intent detected by the machine learning model and with some pre-filled response templates. And once again, they may use the templates or they may discard them and write up their own answer. Okay. So how do we make such a system? We need a tool that will first understand the query, understand the user's intent, then pick the right scenario, then fetch the data from the appropriate dataset, database or service, and finally generate the response in natural language. And importantly, this is a scenario-based system. Okay, this is not a sequence-to-sequence model like ChatGPT. So machine learning is only present in this first stage, query understanding. And all the following steps can be handled with a rule-based system. And this way we avoid hallucinations and make sure that the answer is always reliable. So the heart of the problem is query understanding. Okay, so let's define the task. Actually, most of customers' intents are repetitive. So we can catalog them and then group the messages into clusters, and then whenever a new query comes, we can ask the question which cluster does it belong to. So it's a multi-class classification problem. But then when the new incoming query doesn't match any of the predefined intents, then we say, oh, we have discovered a new intent. And then this is a binary classification problem. So for both of those problems, we're going to measure the F1 metrics, and then additionally, we're going to use some old school clustering metrics like mutual information and rand index. And we're going to aggregate all of those metrics and call them an overall score. Okay, let's try to solve the task. The first baseline approach is to take all the messages sent by Allegro customers, embed them with a language model like BERT, and cluster them. Okay, and this works not too bad on benchmarks. Like it scores 42% on Banking 77. What is that data set? Banking 77 consists of queries sent by customers of a bank to customer service, and each query corresponds to exactly one of 77 possible intents. All right. At Allegro, we can use a BERT that is pre-trained on the corpus of all messages between customers, CX, and merchants. And then we get something like 35%. All right, but obviously we can do better, right? Because the embeddings here in this approach, they are static, and we can make them trainable. So the next easiest approach is supervised learning, so classification. And this works really well on the benchmark. You see a huge boost in the score, but it results only in a small improvement on the Allegro data. So why is that? Well, because benchmarks are nothing like the real world. Okay, so for instance, this dataset, Banking 77, it has 13,000 queries and 77 intents, and each query corresponds to exactly one intent. And at Allegro, we have 68 million conversations, like both questions and answers. And then 105 known intents and hundreds of other intents that we don't know. Okay? And the 105 known intents, they cover only 46% of the whole data set. And on top of that, of course, the whole thing is ambiguous and imbalanced, and that is real world. So can we anyhow leverage the unlabeled data? Because it's no wonder that supervised learning doesn't give you a 60% score on the Allegro dataset if most of your messages don't have a label. Well, yes we can. Let's use semi-supervised learning. So once again, we start by embedding all the messages, and then for each batch, we calculate the matrix of cosine similarities between the messages, both the ones with the labels and the ones without the labels. And obviously on the diagonal we have ones, and let's take two messages, one with a label and then the other one without a label, and let's say that they have a high cosine similarity, so it's denoted with dark orange score in this plot. So then we say that the other message that has no label, we assign it a pseudo label. We say it's the same intent as the former message. So in this way, we increase the number of labels in the dataset. And these embeddings are trainable, so as we train the model, we get finer and finer clusters and more labels, up to full coverage of the data set and fine compact clusters. Okay? So leveraging the full data set gives us a boost of 13 percentage points, which is not reflected on the benchmark. But perhaps we can do better. Well, what are the other differences between benchmarks and Allegro data? As I mentioned, we have full conversations, questions and answers. Can we make any use of that? Yes, we can. Instead of using the standard BERT architecture, let's equip our encoder with 3 heads. One for the question, one for the answer, one for the full conversation. And then we're going to use the male BERT pre-trained on all messages only for the initialization of the encoder. So using the adapting the architecture to the conversational structure boosted our score further to 66%. That's great, but can we do even better? Well, real world is tough, but sometimes you may get gifts from heaven. And for instance, at Allegro, we have a legacy dataset of around 2.5 million emails with tags. These tags are like keywords that were assigned to the emails from customers in a bit messy way before the times of machine learning in CX. Okay, so but you can still treat them as like noisy soft labels for weak supervision. And that's what we did. So instead of using the male BERT encoder, you first fine-tune it on those messy tags in a classification setup, and then you use that modified backbone to initialize the 3-headed encoder. And then you get a boost of another 17 percentage points. That's cool. So what it means is that the knowledge that was injected into the backbone by weak supervision on those noisy labels, that it actually got successfully transferred onto our downstream task. This is great. So how do we deploy the model? Well, what I've shown you is essentially representation learning, right? We embed the messages and we give them pseudo labels, then we cluster them, then we summarize the intents in the clusters, and finally we pass the results to customer experience. And there, the consultants, they confirm the detection of new intents, and they decide on the edge cases. So this is actually the entry point for business, where they fuel this cycle of active learning with domain knowledge. Okay, so what did we learn from this story? Well, first of all, that benchmarks are nothing like the real world. Okay. Secondly, that fancy architectures that excel on benchmarks may not give you a boost in metrics on production. And finally, that domain adaptation and clever use of all the data that you have, it actually makes much more sense than, billions of parameters and millions of petaflops. Be clever. All right, so how do we do domain adaptation at Allegro? First, we create a high-quality corpus. And then we adapt the model architecture to the exact task. And we pick tricks from SOTA selectively and wisely. Okay? And finally, we make good use of our annotation resources. So we either engage them in an active learning loop, or we replace them with automated metrics. And of course, this is not the end of the story, because you can do NLP much better, right? And for instance, in customer experience, we are now undergoing a transition from predictive AI, which is what I just showed you, to generative AI, where you retrieve the answer instead of following a rule-based scenario. And likewise, our machine translation team is currently working on things like zero-shot translation and cross-lingual transfer. But this is just the tip of an iceberg, because our team has developed models that work on production in ranking, retrieval, computer vision, and so on. And at the same time, we do pure research work on things like model robustness and calibration and multimodal representations and so on, many, many more. So who's behind all that? Well, we are a team of over 40 engineers based in 7 cities, and the core of our work is making Allegro, which is great because people love our product. It's really cool. And crucially, at Allegro we have a lot of data and adequate compute, and there is an army of people who will just make sure that you can really focus on modeling. No BS. And above it all, we have a business environment that truly stimulates machine learning research. So the business owners will come and ask questions that require, like, there's no off-the-shelf solution. Okay, so if you invent something really cool, then you can actually publish it at a machine learning conference. Each of our engineers gets at least 20% of their time for research and self-development. And if your research idea has a proven business impact, then you can actually turn it into a production project, full-time. Last but not least, we are hiring. All projects, all seniorities. So please check out our website. That's the QR code on the left-hand side. Or play with our open source models. That's the QR code on your right-hand side. And we're happy to take your questions. Please come over to the hallway. We're there for you in the sponsor booth of Allegro. Thank you very much for your kind attention.
Thank you. Okay. And you're in charge, actually, because you have microphones. I'll provide the instructions. Ola, you ask,
Right.
do you have any questions?
Do you have any questions?
You see? Yes.
Here you go.
Thank you for a very nice talk. Maybe one question about the clustering you used. You used k-means. I can imagine that it's kind of due to experience that you already have because of the domain space, but have you also considered hierarchical clustering, and why not? And yeah.
Yes. However, the taxonomy, it's also hierarchical, and it changes over time. So I would say k-means is a pretty good universal working horse. It turned out to be good enough for the application. It totally makes sense, but I would say that this floating taxonomy of intents is quite a challenge here.
Thank you. May I have one more question?
What do you think?
Thanks. Coming back to the broader architecture you described, what is the impact of this corner case refinement? Because I conclude based on what you said that it has a major impact, and that's why you actually used it. But yeah, what actually was it? And
Yeah, okay. So actually for the translation of offers and products, it is a major thing, because imagine that actually you have a small brand, Polish brand that is called, I don't know.
Żywiec, translated livestock, yeah?
Yeah. So there might be like lots of like funny examples in which you will translate something that should be a brand name, but yeah, like in the end it looks very funny. So that's why it is a major thing, at least for the tasks of offer and product translations.
Thank you.
Any other questions?
You see? She's better chairman than me.
Hi, thanks for the great presentation. Quick question, maybe not very technical detail, but when you work over this model, what was the objective from the business when they say that, oh, it's good enough, let's go prod?
Mm-hmm. Yeah, that's a very good question. So at least for the machine translation project, for us, we had some, let's say, minimal level of acceptance rate that we were given from the business. That, for example, in case of this and that % of translations, we can make minor mistakes, and if they are major, we should not go prod. In case of other projects in which we can run like proper A/B testing, there are like many other metrics that we can use that are based on like, I don't know, for example, click-through rate or other things. But in case of machine translation, it was this. For the intent discovery,
maybe in terms of machine translation, like if you're on par with the best off-the-shelf architectures, then what else would you like? Like, this is good enough for any business.
Yeah, but on the other side, you said that you had a biased annotators.
Yeah.
So the test, the evaluation at the end was somehow blurred.
Yeah, to say it straight, we couldn't beat the biggest vendor because the annotators used it. But once they were disciplined, we beat the biggest vendor. We had to remove the bias. Okay.
Okay.
And regarding customer experience, well, you know, it's there are no KPIs on firing people. Essentially, it's not like we want to save 200 FTEs. No, it's more about the flexibility. That, as I told you, we got 20,000 queries normally. Before Christmas, it's 35,000, and suddenly you have to what? Hire 200 more people because you cannot cope with the questions. No, like automation, it makes the CX much more like agile and adaptable to the traffic, whatever it is. And the metric here was actually how what is the volume of messages that is covered by our assistant, where we actually detect the intent. And one last thing is that why I said this is not such a straightforward project is that, you know, even if the model is great, you may still have problems with acceptance, with adoption. So even if the response that you get from Alina is great, many people still wanted to send their message to the merchant. So it's not just an ML issue, it's an acceptance issue involving UX and other aspects.
Yeah, sure, thanks.
Yes, maybe I'll deliver the microphone, but yes, can I? Yes.
Jacek.
Okay, so last two questions, okay? Please.
I have a question. Why do you translate a title of the product without the context of description? Won't it be easier to translate it with this context of description?
It's a very good idea, and I guess that it was tested, but I don't recall right now like immediate results. If there is like context use, Jacek.
I don't know.
I think.
I've heard.
Yeah.
I do know, but I won't reveal it at the moment because there is a last question there. Okay, please.
Thank you. For this student-teacher architecture, you have chosen classic transformers, right? For all four of them.
Yeah.
Have you also thought about something else? Because
yeah, it is actually we've evaluated like lots of other architectures, and to be honest, vanilla transformer performed like on par. There was no significant difference in the results, and yeah, it is the Occam razor, I guess, thing that if you don't have to overcomplicate, let's go simple.
just maybe to follow up,
Yeah.
Was there a strong competitor to a vanilla transformer?
Ooh, I would have to take a look at the results. I don't remember now,
Right.
but it was a very like important thing that we were experimenting with. Yeah.
Thank you so much. Great talk.
Thank you.
It was a great talk. Thank you, bravo, congratulations.